Okay, ini merupakan exploded version. Gambaran exploded version. Dalam exploded version kita boleh nampak lagi teliti apa yang barang apa yang ada dalam sebuah mesin tersebut. So ini merupakan holder profile yang akan memegang feeder. Ini feeder. Ini roller holder yang akan memegang dua roller tersebut. Ini shaft screw. Beza normal screw dengan shaft screw adalah shaft screw lagi memanjang daripada skru biasa. Dan ini pula ini specially designed for motor roller, sebab roller ni ada gigi dalam dia. So supaya yang dia punya gearnya dia berfungsi sebagai gear. Bila kita couplekan dua benda ni, motor dengan roller, dia akan cengkam dan boleh berpusing, dan dia boleh bawa roller tu mengikut kelajuan servo motor. Ni dua roller. Itu sahaja. Terima kasih. Okay, ini pula dia join version. Dia, bila kita dah fix semua, dia akan nampak inilah sebuah mesin dia. Sebelum kita membuat improvement yang tadi yang kita dah buat improvement ada dia punya alas kat bawah ni. Ada profile kat bawah ni. Ni yang tanpa profile yang sebelum improvement. So ini dua profile, feeder, belting, roller, motor, dan contoh carton box tu seperti ni. Itu saja. Okey, ini rekaan saya. Rekaan saya kat sini ada dua profile ni akan berfungsi sebagai feeder holder. Dia akan hold feeder ni pula ini merupakan vertical feeder. So bermakna kita akan masukkan kotak ke arah gini. Dan ini contoh kotak dia. Bila kita loading kotak dari atas dalam vertical form, kotak akan jatuh di sini. Dan bila servo motornya berfungsi, bila kita onkan servo motornya, roller akan berpusing. Dan ini roller pembantu ni akan bergerak. Maka dia punya conveyor akan bergerak. So kotak ni pun akan bergerak lah. Pada mulanya dua profile ni saya tak cadangkan. Ini merupakan improvement yang diminta saya buat. So profile ni pada mulanya bila tiada profile, conveyornya akan seperti tiada alas. Bila kita meletakkan di atas meja, prototipenya kita letak di atas meja. So saya bercadang untuk mengadakan profile tersebut supaya dia mengalas ataupun menggenggam meja bila kita siapkan prototip dan kita test. Kat belakang ini pula pun ada satu profile yang akan hold akan connected to the roller 2 ni. Dan daripada profile tu kita akan menyambung profile ini. Ini akan horizontal. Ini pun akan horizontal juga, tapi dia arah 90 degree. Gini 90 degree. So ini akan berfungsi sebagai alas supaya beltingnya tak akan kena dia punya meja lah. This is it. Thank you.
Good day, doctor. I would like to explain about my 3 sketches related to material handling machine configuration A. So this is the first sketch that display the concept of full assembly. This sketch clearly show the placement of vertical feeder, and the structure of conveyor based on my understanding of the concept. From this picture, you can see the vertical feeder the vertical feeder I put in the left hand side of the conveyor, and then the boxes will be passed through from the vertical feeder to the conveyor on this direction. So this will be my concept of conveyor based on my imagination and also my concept for my group. For the next sketch is the exploded version of the previous sketch. Here my sketches show the component comprise the material handling machine, which are, you can see here, the roller, and this is the drive pulley, and then followed by secondary pulley, primary pulley, and this is the motor, and this is the wires to connect to the motor and battery, and also here another roller. This linear guide is the linear guide for the conveyor belt to be moved around, and also this is the vertical feeder. So I use this carton, hard carton box material as frame, and also this is the vertical feeder which is designed by through my concept. So next, the final sketch explain about the functions of the material handling machine drawn in first and second sketch. So this sketch basically explain on the functions of each component which play a part on this concept. From here you can see that I already fixed the secondary pulley and drive pulley over here, and then the motor I fixed over here. When we turn on the motor, the secondary pulley will be like make the conveyor belt to move in this direction. Okay, so this is a vertical feeder. According to our PDS, we already designed last class on the distance between the conveyor and the feeder, that is 12 centimeter, and then the box will be dropped from the feeder to the conveyor. That's all on my explanation. Thank you. This is the modified versions of the previous sketch. So from this sketch you can see that I add segment for each box. So you can see here, so the distance between the boxes should be 10 cm. So I put in the center the segment 5 cm 5 cm, so it will be easily to the box to travel through the conveyor. So these are my modification. Thank you.
Greetings to Dr. Khairul and my fellow friends. Today I would like to talk about my full assembly concept of my conveyor sketching. Okay, so my design is based on three major components, which is the vertical feeder, the conveyor belt, and as well as the servo motor right here. Okay, so what I've done here is I've already declined the conveyor to a 30 degrees angle, so that when the box drops from the vertical feeder, it will have a less friction compared to a parallel plane. Okay, so I think it would be a good suggestion to decline it slightly 30 degrees so that it could flow down smoothly on the conveyor. Okay, this is a exploded version of my drawing. Okay, right here we have the frame guides for the feeder, vertical feeder. Okay, so this vertical feeder we will have 1, 2, 3, 4, 5, 6, a few screws to join it all together. The screw that we are using is shaft screws, and all the profiles that we are using here is made out of metal. Okay, so once the carton box are located from the top of the vertical feeder, the box will be dropped from the bottom of the feeder, and it will go through this motion. Okay, right here you can see that I've already segregated each box with a plank, and then I have also distanced them at 10 centimeters apart. Okay, the servo motor that we are going to use is 12 volts of warm gear high torque DC motor. Okay, I think this motor is sufficient enough for the belt to convey its speed at a 30-second, or to meet the requirement of 30 seconds for the whole process.
Selamat pagi doktor. Yang ini adalah konsep development konsep saya di berpandukan abstract and problem solving PDS yang kami telah buat sebelum ini untuk menyelesaikan masalah di mana pengeluaran dari kotak daripada vertical feeder 3 kotak dalam 30 second dan jarak antara satu kotak adalah 10 cm. Ini adalah konsep saya di mana ini adalah vertical feeder, ini adalah moving platform. Moving platform ini akan condong sini ke sini dalam darjah 30 darjah, di mana apabila kotak keluar daripada vertical feeder dan jatuh ke moving platform ini, yang mana dia akan jatuh dan tergelonsor sampai ke stopper. Ini adalah satu stopper yang akan bergerak dengan moving platform dengan jarak yang fix. Ini akan membantu mengekalkan jarak antara dua kotak di mana 10 cm. Ini adalah konsep yang full assembly, dan ini adalah exploded vision, di mana untuk melaksanakan projek saya barang-barang yang diperlukan adalah roller, stopper, conveyor, bateri dan motor dan belt yang dimana sambung dengan puli dan attach pada roller tersebut, supaya moving platform ini akan bergerak dengan speed yang constant. Ini adalah stand, yang ini adalah vertical feeder. Ini adalah dimension dengan exploded with explanation, di mana saya akan pasang vertical feeder pada stand conveyor tersebut dengan jarak 12 cm, yang mana kita telah buat kajian mengikut PDF. Jarak yang paling sesuai adalah 12 cm, dan saya akan letakkan stopper dalam moving platform ini adalah antara 18 cm antara dua stopper, di mana kelebaran satu kotak adalah 8 cm. Apabila kotak keluar daripada vertical feeder ni, akan tergelonsor dan stop di bahagian stopper ni, di mana kita tolak dengan width of the box. Lepas tu jarak yang tinggal adalah 10 cm. Ini akan membantu kita untuk menyelesaikan masalah di mana antara kotak adalah jarak 10 cm. Angle saya akan, walaupun konsep saya 1 meter, saya telah membuatkan 40 cm pada dengan darjah 30 darjah, di mana slide untuk membantu dengan force gravity untuk kotak tu tergelonsor dan stop di bahagian stopper. Dan apabila tercapai lepas 40 cm akan menegak 90 darjah menegak, dan proses ini akan berterusan. Sama juga bateri yang saya akan digunakan adalah 30 watt dengan motor dengan belt. Stand buat daripada besi. Jumlah costing anggarkan untuk menyiapkan design ni adalah RM900. Terima kasih.
Hi, good evening, doctor. So I'm from Group A. So this is my concept for design for material handling process. So first, this will be the vertical feeder for the carton box to be placed in, and so basically this is the rough sketch. So we have the support and also the DC motor. We'll power up with battery, and then we'll have a pulley system over here, so it will make more efficient for the belt to move. And also I've placed a roller on top and at the bottom of the profile, so it will be much smoother movement of the belt. And at the front there's a roller where the conveyor belt sits on it. So next, so this will be the labeling. So it's basically the same thing. Top and bottom will have roller and the DC motor and the pulley system. So the material we use for the conveyor system is, my suggestion would be aluminum frame. So I believe it's much cheaper, the cost. So this is the full assembly concept. So it's basically will be like this. So the conveyor belt system consists of two pulleys. That means the pulley will be here and the roller, and the DC motor is placed at the side of the conveyor system. And you can see the vertical box feeder, it will be held by a frame, and then we'll put in the box over here and it will land on the conveyor belt. So this concept is for the first matrix evaluation that we used. So then once we are doing the Pugh matrix evaluation, so I have added a separator here, as it is as 3, so it will be evenly distributed by 10 cm. So the purpose of this modification is to separate each box within 10 centimeter, because that's our requirement. So I think that's basically about my concept. Thank you, doctor.
And fellow classmates, this is our first evaluation of matrix. As we know, we have developed 5 concepts which are individual concepts, and then we choose the best or the highest point on the first evaluation matrix will be our final concept or final of our design. As we know, our problem was after the box discharged from the vertical feeder should be 10 cm distance between each boxes. After our group has designed the individual concept, we use first evaluation of matrix to choose which one is of us is the best concept. First, the objective of evaluating number option against the number of criteria. As our first evaluation of matrix, we have a few mandatory criteria such as functionality, simplicity, cost, easy to assemble, safety, rigidity, ergonomic, and aesthetic. And then this was our score. Was after discuss with each other group member, we have developed our scores using the mandatory criteria such as functionality. Criteria of functionality explained as able to convey evenly each box from the outflow output from the vertical feeder, then able to equally distribute each box by 10 cm before they reach 100 cm, able to complete operation in 30 seconds. As we know, 5 concept, for mandatory criteria for 8 mandatory criteria, Dinesh was called the most highest score, which was 192 for the overall. His concept was chosen as our final concept.
Good evening, doctor. So this is our Pugh matrix evaluation. So we have 8 criteria. So this 8 criteria is from the first matrix evaluation. So the first one will be functionality. So are we able to convert each box out from the vertical feeder? Second will be, is the box equally distributed by 10 centimeter? Are we able to complete the operation by 30 seconds? Simplicity is efficiency of the machine. Cost is cost effectiveness of the machine design. Fourth is easy to assemble or disassemble. Fifth is safety. So are we able to comply with the Factories and Machine Acts in terms of operational and safety? 6 is rigidity. So is the machine rigid enough to withstand the deformation and perform its operation? And 7 is ergonomic. Is the machine designed ergonomic for human or operator in the working environment? 8 is aesthetic. Is the machine designed in terms of industrial design appearance? So we have a weightage score for each of the criteria. So this will be our re-evaluation for all the 5 concepts, including the champion from matrix, the first matrix. So from the Pugh matrix, we can see that the highest score obtained was concept 5, and it with the highest score of 32. So this will be our champion for Pugh matrix. So I think in the next slide we'll share our final sketches of the design concept 5. Yep. Thank you, doctor.
So after we have done the Pugh matrix, we have decided to go with this particular drawing as our final concept for the conveyor belt. Okay, so what we are doing, what's the difference between the first one and the last one is that I have added a box collector here for the carton boxes once the process is complete to be collected at this particular area. Okay, so most of it, all of our team members have agreed upon the dimensions and the concept of this drawing. Okay, so basically there would be a 12 centimeter distance from the platform, from the conveyor platform to the vertical feeder, okay, which is sufficient enough for the box to drop after consecutively for the box to drop after each boxes, and the distance between each boxes will be a total of 10 centimeters. Okay, so the conveyor motor, the motor that we're going to use for the conveyor is going to be the same 12 volt high torque DC motor. Okay, this motor we can purchase it from Lazada or Shopee. Okay, and furthermore it can be set at a rotation per minute, 3 different types of rotations per minute. Okay, which is very helpful for this conveyor, so that we can set the timing it takes for them to complete the work process for this cycle. Thank you.